Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 14th. Looking at significant wave heights for the South Pacific Ocean, we see remnants of a gale still producing 28-foot seas southeast of New Zealand, aimed well to the northeast, and there is, we'll just say it, swell, yet another swell, in the water pushing northeast. Let's get into the details. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough, just like this, a push in the jet to the north. That helps set a clockwise flow aloft in the upper atmosphere and down at the surface, and that is the hallmark of low pressure in the southern hemisphere. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate north of the fetch area, turn into swell. And swell, when it hits your beach, turns into waves. All right, so we have a trough, persistent trough. This pattern has been in play for 2 weeks now, troughing under New Zealand. It started out mainly just a little tiny trough, and now it's far more pronounced. Okay, this is good news. So we got, 130 knot winds pushing to the northeast. This definitely supports the formation of gale. We'll roll this out. Kind of weakens, but continues moving off into the central Pacific into Tuesday. Still favorable for gale development. Now over here in the southeast Pacific, jets falling south. Here's the northern branch of the jet. This is the southern branch of the jet. When you get this split pattern like this, you get high pressure, and that tends to lock down the South Pacific. And here we go, as we get into Wednesday, more wind energy starts building under New Zealand, pushing off to the northeast at about 150 knots. And there you go, another good trough. That should support gale development. And then that sort of fades, but then reestablishes itself yet again by next weekend, and we're off to the races yet again. I mean, this very much looks like what we should have been seeing back in July, but we didn't. And why is that? Well, that's because La Nina was in effect, and La Nina tends to split the jet stream in the southern hemisphere and just stomp on swell to production. But La Nina is gone now, and apparently the atmosphere is starting to sense that it's gone and starting to, there's a bit of a El Nino-ish type pattern trying to develop over the Pacific, and the jet stream is responding in kind, as well as there's a bit of a active phase of the MJO that was in effect. And so all these things are combining to help support gale formation under New Zealand, and a pretty long-lasting and healthy pattern it is, at least until we get about a week out. Then we'll see what happens. So next up, let's take a look. Surface level pressure and surface level winds. We know that trough is right here, and what do we get? 40 knot winds pushing well to the northeast. That should be generating swell, and that swell would push well towards Hawaii and the U.S. West Coast. Now also notice on the other side of that trough, there's a ridge over here, winds pushing to the south. That does nothing to generate swell, but that doesn't cancel any swell out that's generated by this. All right, and rolling along, more fetch continues as we get into Monday, 35, 40, maybe a small area, 40 knot winds, let's say. That fades out. Still, then here we go, Wednesday. Another trough develops. Winds pick up 40 to 45 knots. There you go, 45 knots to the northeast. Exactly what, almost 50 knots and lifting to the northeast. That's what we want. Look at that. That's great. Just to the north and northeast. Certainly, if that were to happen, swell would result for Tahiti, Hawaii, U.S. West Coast. Nice little system projected. Then it fades out as we get into Friday. But then even secondary fetch, little patch of 35, 40 knot winds, probably mainly focused more on Tahiti. Sure, you need 40 knot winds really to get swell to make it up into Hawaii and the U.S. West Coast, but you've heard that before. Still, good pattern continuing basically for the next week. All right, let's go take a look at the effect of those winds on the ocean surface. So what we didn't say was there was a similar gale under New Zealand 9 days ago or so. That swell is in the water. So there's swell hitting California, right? Okay. It's been, let's start like Friday, Saturday, Sunday. Pretty good size on Saturday. Santa Cruz, maybe 3 feet overhead on the bigger sets, the best spots, something like that. Southern California doing pretty well, too. Maybe 2 feet overhead at the best spots there. And that swell is starting to fade, but still a third pulse of that swell is expected by Monday and should continue with energy in the water pretty much the whole way through the work week. Well, while that goes on Friday, this is like 2 days ago, another system formed under New Zealand. Here you go, 32-foot seas Friday morning, building to 38-foot seas. Well, we'll call it 37-foot seas. Aimed pretty well to the northeast, lifting northeast, then fading on Saturday. That swell is in the water still, 29-foot seas on Sunday. And that swell's in the water now, pushing north. It'll arrive, Hawaii in a week, so that would be maybe next weekend for Hawaii, and beyond that for the U.S. West Coast, maybe 10 days out. And then let's go look out beyond that. We know this trough is going to continue to be productive. Here we are tomorrow, Monday, 30-foot seas, all aimed south, of no interest to us. We know there's something supposed to blow up on Wednesday. Here it comes. Wednesday, 31-foot seas as of Wednesday morning, building to 40 feet on Wednesday night, pushing to the northeast, 40 feet continuing into Thursday, and then fading from there while lifting northeast. That's yet another push of swell for a week and a half out beyond that. So, the short of it is, it looks like summer is here, and you're just going, really? Summer in practically 2 weeks from Halloween? Well, you take what you can get, and it's not only the southern hemi that we have to look at, but let's just roll this out. Another little system, even a week out, Saturday night, small area, 30-foot seas pushing northeast. Maybe some background swell from that for yet a week beyond. This is for Sunday. A week from today, and swell a week after that. So we're looking for basically southern hemi swell through Halloween, if you believe the models, but odds are probably pretty good. And then you say, well, wait a minute, shouldn't the northern hemi be doing something? So let's take a look at the jet stream. Jet stream actually is looking better now than it was. This place, the North Pacific's been locked down by high pressure. Again, the main effects of La Nina are more strongly felt in the northern hemisphere than the southern hemisphere. Right now, the jet, it's okay. It's, you want to see it at about 40 north, which it is, sort of, but not a lot of wind energy in it. You can really want to see like 150, 160 knot winds, but at least we have some sort of a flow pushing east on the 40 north latitude line, over the date line, and then kind of a trough as we get into Wednesday, Thursday, but generally the jet still sort of looking like a La Nina jet, pushed off to the north a bit, weak, not a whole lot of energy in it. At some point that will change, but just not right now. And typically it'll change when the southern hemisphere shuts down and you see the jet starting to build in the north. Then you know that we're going to transition to a real fall pattern. But for now, it looks like summer, for the most part, is going to continue. That said, looking at the wave models from yesterday, Saturday, small gale did develop on the north dateline region. Seas building to 39 feet over a very small area aimed southeast. And then into Sunday, that's today, again 38 feet. And then fading as of 18Z. Let's go take a look at the forecast for we get into Sunday night. Seas fading 32 feet, and then pretty much that's the end of it from there. Most energy pushing off to the east, targeting the U.S. West Coast, but the issue is most of this energy is in the western Gulf and dateline, so it's anywhere from 1,800 to 2,400 nautical miles away from California. So whatever swell gets there will be pretty small. And it was north of 45 north, so pretty north angled relative to, San Francisco area. Central California will do okay, but still pretty north. Not giant size. Hawaii, we'll see energy from this too. Maybe 8 or 9 foot Hawaiian, something like that, but nothing huge, nothing strong, nothing long lasting. But it would be a second pulse of swell. Good swell, what was that, a week or so ago? Maybe earlier this week, I'm trying to remember. Anyway, one good pulse they got, now another, and the U.S. West Coast gets to share in some of that. Let's roll this out anyway, take a look at what's going to happen the rest of the week. Small gale develops, does it do anything? Yeah, maybe builds, what's that? On the dateline, 28-foot seas, 20-foot seas, something like that, but not a real fall pattern yet. Most of the focus still at this point in time is the South Pacific. So that begs the question, what's going on long term, out beyond? What's going on with the MJO? First, we like to look at the Madden-Julian oscillation. That sort of tells us when there'll be opportunities for storm development, either northern hemi or southern hemi. MJO, when in the active phase over the Pacific, lasts there normally, in active or inactive phase, maybe 3 to 4 weeks, and that's when you get storm cycles, and then your odds for getting swell, and then sometimes rain and snow increases. In the inactive phase, the exact opposite, high pressure and sort of a lull in the pattern. Of course, what's going on with a supposed development of El Nino? So we like to look at what we call the Kelvin wave generation area. That is winds across the equator. Here's the equator. This is the East Pacific here. This is the West Pacific here. That's New Guinea. We see, and this data is from the TAO buoy array, series of buoys strung across the equator. We see winds from the east, and so from the East Pacific, Hawaii's like just about 158 south, so Hawaii's up there somewhere. And then the date line here, 180, the Kelvin wave generation area, we call it, from 170 west, 5 degrees north and south of the equator. When the active phase is over here, you tend to get westerly anomalies, and let's look at winds. Okay, so this is actual winds, but are the winds stronger or weaker than normal for this time of year? That's the key here. We sort of look at the arrows here. They say, oh, they're actually kind of blowing from the west lightly. That's good, but we need to see westerly anomalies in the Kelvin wave generation area right here. What that tends to do then is take warm water that's always in the West Pacific, push it down to depth, creating a thing called a Kelvin wave, a ball of warm water, pushing it off the east, eventually erupts off of on the ocean surface off of Ecuador, creates a warm pool, and you see right now temperatures 1, maybe 1.5 degrees above normal here on the equator. This is all what El Nino is about, right? Warm water on the equator. We see warm water here also back out towards the dateline, but it's over here that you really want to see it, and that tends to push the storm track east and amplify it, and that in turn sets up, your typical El Nino, lots of storms in the winter kind of thing, and even in the summer as well. Right now, we're seeing kind of a neutral phase of the MJO, no westerly anomalies here in the West Pacific. What's been going on the past 5 days wind-wise? Well, here's South America. There's the equator right there. Australia, there's New Guinea. Kelvin wave generation area right in this area here. You're looking for arrows pointing from the west to the east in reds and orange. Those are westerly anomalies. We see them all here in the East Pacific. This is what was the active phase of the MJO. It is fading. You can see blues building easterly anomalies as of October 11th here in the Kelvin wave generation area. That suggests the inactive phase of the MJO is moving into the Pacific. The active phase is moving out, and so that would suggest a lull in the storm pattern for the Pacific. Here's a retrospective look and forecast of this is wind anomalies for the entire for the entire planet. The date line runs right down the middle of the picture, so the Kelvin wave generation area, West Pacific, would be between these two tick marks, and you just go down. Here's past history. See oranges, purples, these are westerly anomalies, kind of all the second half of September westerly anomalies. Then here's the big blob of westerly anomalies that's starting to move. That same pattern is moving off to the east out of the Pacific, and we see here's the forecast. Easterly anomalies trying to build into the Kelvin wave generation area between these two tick marks. It was really kind of hyped up a week or 2 weeks ago, and we're going, oh my gosh, a very strong burst of the inactive phase is supposed to develop. That'll stomp on El Nino for sure. But now we're down to, well, it started when, let's say, October 9th or 10th, and it kind of looks like it's all going to be out of the Kelvin wave generation area by October 19th. That's a 10-day run. That's not much of an inactive phase of the MJO. That's exactly what we want to see. Then you almost look down here and you say, well, by 3 days from now, weak little westerly anomalies starting to build in the West Kelvin wave generation area and starting to fill it a week out. That's good news. So a little bit longer range view of what's going on with the MJO. All right, so outgoing long wave radiation, that is how much sunlight reflectivity off the ocean surface are you going to get over the next 2 weeks. That is, if you see these yellows here, that means more positive numbers, more sunlight reflectivity. That means high pressure. That means the inactive phase of the MJO. See blues, that suggests less sunlight reflectivity, more clouds, meaning the active phase of the MJO. So yeah, we're in the inactive phase, but it looks like in 5 days per this model, the statistic model, it's supposed to die. Then we kind of get a weak active pattern, active light pattern developing, but it too dies, and we just basically go to neutral. The dynamic model, though, suggests inactive phase, fading a little, then rebuilding. And these two models have been at, opposite ends of the spectrum for a couple of weeks now. But in essence, it kind of looks like the statistic model is closer to the truth than the dynamic model. The dynamic model's been hyping this easterly wind anomaly, inactive MJO thing, and the closer we get to it and the closer we get to it, the weaker and weaker it's looking. So I'm not necessarily believing that this strong inactive phase 2 weeks out is really going to happen. Upper level model goes out 40 days. The yellows and oranges are areas not favorable for precipitation, meaning the inactive phase of the MJO, and that shows it just gone and out of here by October 24th, and the greens are favorable for precipitation, meaning the active phase of the MJO is starting to develop in the West Pacific as we get into mid-October and making its way the whole way across the Pacific through into mid-November or so, followed by another inactive phase of the MJO. Interesting. The CFS model has also been seeming to have a pretty good handle on stuff. What are we looking at here? This is, again, zonal wind anomalies, the east-west component of the wind. Date line runs right down the middle of the picture. The Kelvin wave generation area between these two tick marks. And you can see all of July, August. You just see reds right down through the Kelvin wave generation area. A large batch of reds here. I mean, a lot of westerly anomalies in September. This is all basically what you would say is the developing part of El Nino. It's not a continuous active phase of the MJO, but that's kind of what is happening. That's what El Nino looks like if you look at zonal winds. And so here we go. Here's today. You see a little bit of blues. That's easterly anomalies, and these tick marks here are weak. So what are we looking at? And the Kelvin wave generation area ends like right here. So we're looking at a week to maybe a week and a half of easterly anomalies, while westerly anomalies start retrograding west, filling the Kelvin wave generation area, we'll say 2 weeks out, and then we're back in business again. So if this is an inactive phase of the MJO, it's a pretty weak one, according to this model. Let's go look at the longer-term model. So this one is shown in reverse. That is, past history is down here. The future is looking forward. Kelvin wave generation area between these two tick marks. So the same sort of deal. You go back. We're looking June here. Persistent westerly anomalies in the Kelvin wave generation area. Here is our inactive phase of the MJO right here. What is this? From October 14th to, at least in terms of a wind perspective, to maybe the 20th. And then westerly anomalies redevelop and then get supposedly quite strong from starting, let's say Halloween, the whole way through December. This would be a westerly wind burst. This would be definitely something that could create a Kelvin wave that would push yet more warm water in the West Pacific East. That would help feed El Nino. Let's put the MJO over here. Okay, so here's our inactive phase of the MJO, this dotted contour. Again, just between these two tick marks. That's all we're looking right in here. And you see, inactive phase, and going into, let's say, early November, but westerly anomalies can start rebuilding. That's a sign of El Nino. And then start building very strong as the active phase builds from, first week in November the whole way through till, let's say, the first week in December. And then even after that, we get the inactive phase of the MJO, but westerly anomalies persist, and continuing on into January. So why is all this happening? Let's overlay the low-pass filter. Here we go. And so this, basically, when you see these solid contours like this, and there's the Kelvin wave generation area, they're all just basically almost filling the entire, there's California at 120 west. As of right now, the low-pressure bias is filling the entire Pacific Ocean, according to this. And we're just waiting for the atmosphere to kind of really pick up on it. Change the seasons. We're waiting for La Nina to get out of there. We're at 3 contour lines, forecast to build to 4 as we get into December 1st. Okay, we got the low pressure bias, we got the active phase of the MJO. Those two in conjunction build some pretty strong westerly anomalies, and that should theoretically help build yet another Kelvin wave, and yet deepening low pressure as we get towards the Christmas time frame. So this is all the setup for some sort of flavor. Again, just modeled. Don't know if it's going to happen, but the model's been consistently saying this, and for the most part, the atmosphere's been responding in kind. So it looks like some sort of El Nino is trying to develop. All right, so what's going on in the ocean? Temperatures are key to monitoring Kelvin waves. So East Pacific here, West Pacific here, this is depth. Down 100 meters to 300 meters across the entire equatorial Pacific, 2 degrees north and south of the equator. And this is the temperature profile. You see 30 degrees Celsius, that's warm water in the West Pacific, and then progressively weaker temperatures as you get to the East Pacific. But the key is watching the change in these temperatures, and we see the 28-degree isotherm line slowly, it sat around 160 for months, slowly starting to ease off to the east. The 24-degree isotherm line it was back at 120, it's 100, and pushing east too. That suggests warm water is moving east. Let's look at anomalies, differences from normal for this time of year, and what do we see? This is a Kelvin wave, a good size one too. Warm water, 4 degrees centigrade above normal, south of basically just a little bit west of Hawaii, and moving off to the east, 3-degree Celsius temperatures, pushing almost into the East Pacific, almost to Ecuador, and sort of breaching the surface here. Let's go take a look at a little higher res view. Here you go, right here. Look at this. Now this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5-degree anomalies. This is quite warm. This is a solid Kelvin wave here. This was built by a series of westerly wind bursts. Not so much westerly wind bursts in the Pacific, but we think they were more over the maritime continent, and they started pushing warm water flowing out from here, like north of New Guinea, and then into the depths of the Pacific, and now they're pushing off to the east. This Kelvin wave takes 3 months to make the journey across the Pacific. Probably will arrive sometime in mid to late November in the East Pacific, and then erupt at the ocean surface. That should help fuel El Nino, and that in turn, that warm water should help fuel precipitation in the East Pacific. That should start feeding the jet stream. That would kick off the storm track for sure. Anyway, so what we have noticed this past week is warm anomalies building much further to the east. There used to be some cool anomalies here. There's the last little piece of it right there, 2 pixels worth of blue. That was the upwelling phase of the Kelvin wave cycle. It looks like we're set for, and you see, the other cool thing is there used to be sort of like neutral temperatures right in here. Now it's all warm anomalies from Ecuador the whole way out to the date line and beyond on the equator. This suggests there's a lot of heat energy in the ocean moving east. That should definitely help fuel the storm track at some point in time here in the future. Upper ocean heat anomalies. Upper 300 meters of the ocean's atmosphere going back in time. This is West Pacific here, East Pacific here. We're back a year ago in November. Blues below normal temperatures. This was La Nina. Little Kelvin wave. You can see the warm water pushing across in the January of last year, or this January. Kind of a small Kelvin wave. Upwelling phase of the Kelvin wave cycle. Big westerly wind burst occurred in February, created a Kelvin wave. That made it to the east. Weak, not strong enough, but it did make it in the June time frame. That just put the end of La Nina, got us to sort of a neutral state. Here, right in here, is the upwelling phase of the Kelvin wave cycle. And what is this? Well, we thought that was a pretty solid Kelvin wave. Look at this guy here. Much stronger. Look at the coverage of the deep reds here. You even have deeper reds starting to show up now. This suggests a rather... Oh, and let's do the timing on this one. So it was, let's say, mid-February from here to make it to, we'll say here. And that was February. So that was, what, about 3 months? We'll go 1, 2, 3 months, maybe even 4 months. Well, 3 months to make it across the Pacific. So if this guy was forming in, we'll say September, October, November, late November-ish time frame, maybe early December. That's typically when El Nino is at its peak. Now the deal here, though, is if this were a strong El Nino, all this stuff would have started happening, in February, been really strong. We'd have a big warm pool already off Peru. We do not have that, okay? We're basically all these machinations here are just trying to get La Nina out of the atmosphere and get us to normal and then get us warmer than that. So it takes a lot of energy to do that. So what's going on at the ocean surface? That's ultimately what matters, right? Warm water on the ocean surface in the East Pacific, where normally there is cold water, where normally there are strong trades blowing from east to west, causing upwelling in this area, and that tends to, put cool water off of Peru and off of California for that matter, and, tends to suppress precipitation. What is this? We see a pretty good solid signal of warm anomalies. Now, it's not huge. If it was a big El Nino, you'd see these temperatures the whole way up into Central America, the whole way down into Peru, kind of making a triangle sort of thing here. We don't see that. And in fact, if anything, so last week we had warm anomalies building pretty good along Peru and Chile. They seem to have backed off. We see some cool anomalies building way off the coast here that weren't there last week. But still, we have a modestly warm pattern, but what we do know is way back around over here and down about 300 meters, there's a massive pool of warm water pushing in this direction, and this is the very tip of that warm pool just starting to tickle the ocean surface and erupt there. And what this does then, of course, if you have warm water, then you get more evaporation. If you get evaporation, you get precipitation, and that starts feeding the jet stream and building a more favorable pattern for storm production. Surface ocean temperature trend for the past 7 days, warming along the Galapagos. Not as warm as it was along Peru last week, but still a little bit warmer, certainly not cooling. And of course, warming in random pockets, but it's mainly the official El Nino monitoring region is right here. 120 west, 5 degrees north and south out to 170 west in here. But it's the warming back in here that you get strong warming along the Galapagos. The trades pick it, push it into the El Nino monitoring region, and that's what gets you El Nino. Here's the backed off view. You see our warming. It's not real strong in the south. It looked like it was trying to do something last week, push south. Now it's just limited to maybe 5 degrees south of the equator. Most of the warming is to the north here, which is kind of interesting. There's this persistent cool thing down here that just won't disappear. We really need that to disappear to get a good decent El Nino developing. So here's the temperature trend in the Nino 1.2 area. This is right up along Peru and Chile, mainly Peru and the Galapagos. It was up to about 1.3 degrees back. These are week increments, so 1 week, 2 weeks, almost 3 weeks ago. And still has been kind of warm, but now it's heading down, and we see that in all the other data. It's kind of cooling Nino 1 to 2. That's not so good, but what we really wanted to see was Nino 3.4. That's the official El Nino monitoring region, and here you go. Boom. They said it was going to start rising in October, and it has 0.736 degrees and holding, just toggling there. That's in El Nino range. All you need is 0.5 degrees above normal. Now, that we're not talking a strong El Nino or anything. This is like, only a week, 2 weeks, we'll say 2.5 weeks of temperatures in the El Nino range. So that's not an El Nino. You got to have that for like 5 months. So we got a ways to go, but at least we're not in La Nina territory. All the temperatures here are above neutral, not negative, except for a couple of days worth right there. Generally, this looks, so that at a minimum, this sets us up for what we'll call a normal winter. The issue is, are we going to get something better than normal, something a little bit more enhanced than normal? Guess we'll see. So here's the official forecast from the CFS version 2 model. This is the United States El Nino model for temperatures in the Nino 3.4 region, the official El Nino region. So here's the deal. We were looking at the model. For months, it's we were toggling here at like 1/4 of a degree above normal. The model's saying, okay, when you get into early October, you're going to see 0.75 to 0.8 degrees above normal. And it's like, really? Really? Is that for sure? And That's exactly what's happening right now. This model, the forecast is verifying. So if you believe that, and we know there's another big Kelvin wave coming, and it'll erupt in the late November-ish, sort of this time frame somewhere in here. So there's a Kelvin wave right now. Yeah, that's the one that's pushing under, and fingers of it are erupting at the ocean surface, but it's not really supposed to do its thing in earnest till November. So temperatures are supposed to go up from here to 1.25 degrees above normal and basically hold all winter. Okay, so that would be an El Nino for sure if it were to happen. Now, the downside is, so after El Nino, what do you get? You see the temperatures start heading down. And that suggests as we get into fall of 2019 that maybe we'll be back in La Nina. That would not be good news. And that's why we've been kind of not really wanting an El Nino right now. We kind of almost want this El Nino to fail and not materialize, just so we didn't have to deal with La Nina for another 2 or 3 years of La Nina after this El Nino, because the thoughts is this El Nino is not going to be a strong El Nino. It'll be a modest El Nino. The effects on surf will be, we'll get some good waves, but maybe probably won't be over the top or anything. And the effects on precipitation and snow in California will maybe enhance it a little bit. We might just end up with a normal kind of year. These sort of mid-grade El Ninos, it's really hard to tell what they're going to do. They really have to push some warm water. It really has to build up significantly along the Peruvian coast, and we're not seeing any of that right now. So hard to say what's going to happen. But the good news is, well, we've had some southern hemi swell the past couple of days. That's supposed to continue smaller in California the whole way through the work week. Hawaii, they're getting some swell, but it's southern hemi, not as direct, and it's supposed to sort of fade. But the good news is there's already been another gale under New Zealand. Another swell is on the way. Should be at least as big as what we've just seen, and aimed pretty better at Hawaii, so Hawaii should see more size from it. Maybe, Hawaii a week out and U.S. West Coast beyond that. And then the models say 3 days from now, another solid system under New Zealand. All that said, so there's a whole string of southern hemi swells coming. That's the short of it. On top of that, we've had a gale over the North Dateline. A little bit of north swell coming towards Hawaii, I think around the Tuesday time frame, and into the U.S. West Coast, let's say Thursday, Friday-ish. Nothing huge, but at least a pulse of swells from the north. Mix things up a little bit. So swell is becoming less of a concern now. There's activity. It's like, hey, things are maybe starting to return a little bit to normal. The question is, are we going to go from normal to something better than normal? Well, just keep watching the models, and we'll see how this thing evolves. It's sort of a soap opera that you tune in every week to see what's going to change, and you can predict it, but it's what actually happens at the ocean surface. The 0 hour hindcast. That's what matters. Forecasts and projections are great. They tease you, but they often disappoint. It's what's happening right now that counts. So we'll see how this evolves. Anyway, that's our forecast for this week. We'll do it again next week, same time, same channel. Thanks for watching.